Hello, welcome to Hawk Math. As you can see, I'm here in person in this video, and I will be doing this for most of my videos in the future. Not all, but some of them. And so I hope you like this new style of video. Please let me know which one you prefer, handwritten on a desk or in person like this on a whiteboard. So getting started with this problem, we have the integral from 0 to pi over 2 of 1 divided by cosine x plus sine x plus 1 dx. Now whenever I see a trig expression like this, my first thought is to try to simplify it using trig identities into a better, easier one to solve the integral. However, after looking at this, I don't really see that many ways of simplifying it. So my second strategy is to then go to Weierstrass substitution, especially when I have these trig identities in the denominator of a fraction. And if you're unfamiliar with Weierstrass, that's it's a u substitution saying u equal to tangent of x over 2. Now, why this is important is because if you do out all the trigonometry, you get that sine of x is actually equal to 2u over 1 plus u squared. You get cosine of x is equal to 1 minus u squared over 1 plus u squared. And then you get dx is equal to 2 du over 1 plus u squared. So now when we plug all these in to here, instead of having trig, we'll have only it all in terms of u, our variable, without any trig expressions. So we have the integral from plugging 0 to here, we have tangent of 0, which is 0. Now plugging pi over 2 to here, we have tangent of pi over 4, which is 1. And now we have 1 divided by, plugging in what we have for cosine, we have 1 minus u squared over 1 plus u squared. Now plugging in what we have for sine, we have plus 2u over 1 plus u squared. Then we have plus 1. And then we have this dx, and dx was right here, is 2 du over 1 plus u squared. And this is why having trig expressions on the denominator of a fraction comes in especially handy for the substitution. Because if we look, this 1 plus u squared will cancel out with this 1 plus u squared and this 1 plus u squared. So we can simplify this expression fairly nicely. We have the integral from 0 to 1 of 2 du over, the 1 plus u squared cancels, leaving us with a 1 minus u squared. Then we'll have a 1 plus u squared cancels with here with a plus 2u. And then shipping this right here, we have plus 1 plus u squared. Now we see that the u's cancel, u squared cancel, sorry. And we have the integral from 0 to 1 of 2 du divided by, we have 2u plus 2. And now we notice that the 2's will cancel, so we have the integral from 0 to 1 of du over 1 plus u. And this is very easy to integrate. It just becomes natural log. So we have the natural log of absolute value 1 plus u. And we're evaluating it from 0 to 1, which equals the natural log of 2 minus the natural log of 1. And in total, that actually is the natural log of 2, and we're done with this problem. So this problem is a very interesting problem, and it becomes really easy once you employ the substitution of Weierstrass. And so whenever you see some complex trig expression you don't really know how to simplify, especially with trig on the denominator, or you see, in fact, any of these forms, like a 2u over 1 squared or this in the integral, then try a Weierstrass substitution and see if you simplify that out. I really hope you enjoyed this video. Please like and subscribe if you want to see more like it. And feel free to comment any suggestions down below. And please let me know what format you like, me in person or me doing it on pen and paper on a desk. Thank you for watching.